I hope you have checked a document that I sent you yesterday. There were some solved exercises related to the straight line and all the knowledge that we took there, the gradient, how we can find the gradient from the given graph of a line, or trying to deal with the intercepts, how we can find the intercepts of the line with the x and the y-axis. There were many exercises. Please check them. They are solved exercises. We have this part, finding the length of a straight line segment and the midpoint of a line segment, which we will deal today. And after that, we will pass and try to start with the meaning of quadratics today again. So let us start without losing time. How can we find the length of a straight line segment? Maybe you have done it last year, but we will repeat again. It is easy. Actually, you know that the lines are infinitely long, but usually we deal with only one part of them. And when we are asked to find the length, it means finding the length of the part of the line. That is the line segment. So you are starting from a point and you are ending at another point. If you know the coordinates of the endpoints of the line segment, you can use Pythagoras theorem to calculate the length of the line segment. How can you use the formula of Pythagoras? Let us look at this worked example and try to understand what is happening from the graph. So you have to find the distance between the points 1, 1, with coordinates 1 and 1, and 7, 9. Okay. Look at these lines whose lengths are easily calculated by the coordinates of the initial and terminal point of this line segment. For example, this length 6. How can you find it? You know this coordinate, it is 7, and you know this coordinate, it is 1. According to the x-axis, the first coordinates show the distance from this point to the y-axis, isn't it? So 1 unit and 7 units. So what is this? It is 7 minus 1, isn't it? The 6 represents the difference between the x coordinates. What about 8? 8 represents the difference between the y coordinates, 9 minus 1, isn't it? Because 9 is the distance from this point to 0, and 1 from this point to 0. So just by subtracting 9 minus 1, you get 8. What do these two show? This, in this right triangle, show the lengths of the legs, isn't it? So using the Pythagoras theorem, you can find the hypotenuse. Which formula is it? A squared, or hypotenuse squared, is equal to the sum of the squares of the legs of the right triangle, isn't it? So by using this formula, you are given the two legs, 6 and 8. Just substitute 8 squared 64, 6 squared 36. The sum is 100. So a squared is 100, means that a is 10, isn't it? Because you should have a positive length. That's why you get only the positive result of the square root. So you can find the distance between the points using this formula. So what you actually do is a squared plus ac squared, plus bc squared is equal to ab squared. The same formula, the Pythagoras theorem. Okay, so how can you find AC? What is AC? The difference between the y coordinates, 6 minus 3, isn't it? What about CB? The difference of the x coordinates, isn't it? So you can use even this way, or without thinking of this C, point C, just look at the coordinates of A and B. What is one of the legs? Difference of x is 7 minus 3. Okay, 4. What about the other? The difference of the y coordinates, 6 minus 3, 3. After finding 3 and 4, just use them as lengths of the legs. So 9 plus 16, 25. AB is the square root of 25 equals 5. Okay, so this is the method of finding the length of a line segment AB. But you should be given all the coordinates, both coordinates of A and both coordinates of B, in order to find the length of AB. What about the midpoint? So you are given this line segment AB and you need to find the coordinates of the point in the middle, the midpoint here, which are its coordinates. Actually, when you look at the coordinates of x coordinates of initial point and terminal point 5, it's understandable that the midpoint should be here in 4. But actually, how can you find mathematically this with a formula, this x coordinate 4? If you add and divide by 2 the x coordinates, actually you can find 4, isn't it? So the first coordinate, the x coordinate of A is 3, x coordinate of B is 5. Just add them up and divide by 2. So 3 plus 5, 8 divided by 2 is equal to 4. And the same thing is possible to do when you are finding the y coordinate of the midpoint. Add up the y coordinates, 3 plus 10, 14, and divide them by 2. What you get is 7. So this point here in the middle, the midpoint of the line segment AB, should have coordinates 4 and 7. So it's here in the middle of this line segment 6A, isn't it? So that is the formula for finding the midpoint. We add up the x coordinates, divide by 2. We add up the y coordinates, divide by 2. Okay, as it is explained in the following sentences. If you add both x coordinates and then divide by 2, you get the x coordinate of the midpoint. If you add both y coordinates and divide by 2, you get the y coordinate of the midpoint. Okay? So the midpoint has the coordinates 4, 7. Okay. That was all for the lines and everything related to them. Now we will start with the quadratic and other expressions related to quadratics. Okay, let us look at this diagram. It is a big rectangle composed of small rectangles, some of them squares. This side, let it be the length, for example, of this rectangle is x plus 3. The other side of this rectangle is x plus 5. You know that you can find the area of this big rectangle by multiplying length and width, isn't it? So x plus 3 times x plus 5 gives us all this big area. But also you know at the same time that you can find this area by adding up the 4 small quadrilaterals which form this big rectangle. So this square, because this is a square, plus rectangle plus rectangle plus rectangle will give you the big one. So if you add them up and if you calculate first each of them, you know area of this square is x times x, x squared. Area of this rectangle 3 times x, isn't it? 3x. Area of this rectangle 5 times x, 5x. Area of the last rectangle 5 times 3, 15, isn't it? And when you add this up, you get x squared plus y8x, because these two are similar terms, like terms, so you can add them up. You get 8x plus 15. So actually this represents the area of the same big rectangle. So as a last part, we can say that this product x plus 3 times x plus 5, which was again the area of the same rectangle, should be equal to this result, isn't it? So x plus 3 times x plus 5 is equal to x squared plus 8x plus 15. Actually, you have dealt with this and you know how to multiply these two brackets. But maybe you haven't seen this kind of approach, which is by using geometrical figures, isn't it? So we have used the geometry to try to prove a formula in algebra, isn't it? This is actually true for all the values of x. Okay, notice what happens when you multiply every term in the second bracket by every term in the first. So let's turn back again to the same example. Multiplying x plus 3 with x plus 5 and trying to multiply each term by each term means you have four different possibilities because you multiply this yellow x with a green x, then yellow x with 5 to get 5x, then 3 with x to get 3x, then 3 with 5 to get 15. And when you add them up, you get the same thing that you have done in the previous page. But in the previous page, in the previous slide, we haven't used this method. We have used geometrical method by finding the area. Notice that the four terms in boxes are exactly the same as the four smaller areas that were calculated before. Another way to show this calculation is to use a grid. So you can use this grid. You can place horizontally the two terms of one of the brackets and vertically here the two terms of the other bracket and try to multiply, make each possible product between four of them. So you will get four different products. And these are the four terms actually that you obtain here above when you multiply each term separately. Okay, when you remove the brackets and rewrite the algebraic expression, you are expanding or multiplying out the brackets. So we have used this expanding term before, isn't it? You remember in the previous chapters, we have seen expand the brackets. Okay, expand and collect like terms. We have dealt with this kind of questions. So it is kind of repetition of what we have just done before. The resulting algebraic expression contains an x squared term, an x term, and a constant term, isn't it? Let us look at this example below. For example, when you multiply x plus 2 with x plus 9, what you get after multiplying each term by each term is x times x, x squared, x times 9, 9x, 2 times x, 2x, and 2 times 9, 18. After collecting the like terms here and getting 11x, isn't in the result that you have a term with x squared, a term with x, and a constant term without x. That's what is stated here. And this is called a quadratic expression. This is quadratic expression. Be careful, not equation. To have an equation, this trinomial should be equal to 0 or another number or another term with x. These are equations, so you should have an equality between two expressions in order to have an equation. If it is like this, a monomial or binomial or trinomial in quadratic form, like in this case, that is called quadratic expression only. Okay? Let us look at the question B. You have again to multiply two brackets, but here it has used the grid method. So it has placed horizontally the two terms of the first one. Be careful, minus is a sign of 7, and x plus 6 are vertically placed, and just by multiplying each of them by each of them, you get these four terms. You place them and you collect the two which are in the middle and are both like terms to get minus x. And this is the resulting quadratic expression. For the question C, it has used another way. I remember that you have told me something like this that you have learned in the last year. What is it? When you multiply 2x with x, as they are both of them first terms of the two brackets, they are called firsts. Then outsides means the first and the last. Then insides means the ones which are near to each other, minus 1 and x. And lasts mean the last of the first bracket is minus 1 times last of the second bracket is 9. So doing all these possible products like we did in the previous questions, but naming them by using these initial letters of the words first, outsides, insides, and last, and forming the word foil. Maybe some students have it clearer and easier to use this way to multiply. All of them are the same thing actually and give the same result. What about when you find the product of more than two sets of brackets? Like in this example, you have first bracket times a second bracket times third bracket. So you don't have a product of two brackets only. As you might think, you will have x times x times x. So in the end, you won't get a quadratic expression. You will get a cubic expression, isn't it? You will have an x cubed. But it's not a problem. When you multiply two of them, as you will get a quadratic, we will see this part in this chapter. Okay? So what you do is multiply the first two brackets, or if you want, you can multiply the second with the third, or change their places and multiply in different ways. No problem. Just start with two of them. If you start with the first bracket times second bracket, you will have 3x times 2x, 6x squared, then 3x times 1, then 2 times 2x, 4x, then 2 times 1, 2. And leave times as the second bracket as it is. Okay, you will deal later with this one. Add up, collect the like terms here to get 7x. Now you have this quadratic expression times this binomial, which is linear expression. X is in the first power. What you do is the same thing. You use the same logic. You multiply each term of the first bracket with each term of the second. So you will get 3 terms times 2 terms, 6 terms totally. Okay, like it is shown here. So 6x squared times x plus 7x times x plus 2 times x will make you obtain this first 3. Then 6x squared times minus 1, 7x times minus 1, 2 times minus 1 will make you get this 3 terms. Then you just collect the like ones. So with x cubed, you have only this first term. 7x squared minus 6x squared, it makes you get x squared. 2x minus 7x is minus 5x, and just minus 2 minus 2. So that's all. You obtain this polynomial with 4 terms, whose greatest term is cubic. So that's why it is a cubic expression. Okay. Today's lesson was shorter and easier than the last days. Okay. Are you there?